For decades, the garden industry has sold you a different product for every problem your plants face. Fungicide, pesticide, root stimulants, soil drenches, each one priced separately and marketed as essential. But experienced gardeners who have quietly figured out the truth spend almost nothing solving the same problem. Their secret fits in a brown bottle that costs less than $2 at any pharmacy. Here are 25 ways hydrogen peroxide saves your garden and why nobody in the industry wants you to know. Number 25. It kills root rot without destroying soil. Biology. Root rot is responsible for more plant deaths than most gardeners ever identify correctly. By the time the leaves droop and yellow, the roots are already gone. And the typical response is to buy a fungicide drench that costs upward of $20 per bottle. Most of those products kill beneficial soil organisms alongside the harmful ones, leaving dead, biology-free soil that becomes dependent on more purchased inputs. Hydrogen peroxide at 3% concentration, mixed at 1 part peroxide to 3 parts water, releases oxygen directly into waterlogged soil when applied as a drench. That oxygen is lethal to the anaerobic pathogens responsible for root rot, specifically Pythium and Phytophthora species, because those organisms cannot survive in oxygen-rich conditions. The aerobic bacteria and fungi that support healthy root development are unaffected, because they thrive in the same oxygen-rich environment the treatment creates. Root rot is the invisible killer below the soil surface, and the next application deals with something far more visible, the fungal disease that can cover an entire plant in white powder within 72 hours of first appearing. Number 24. It eliminates powdery mildew on contact. Powdery mildew spreads faster than most gardeners expect. One affected leaf becomes 10 within a week under humid conditions, and garden centers stock entire shelf sections of fungicide sprays in response. Those products require repeat applications, leave residue on edible crops, and carry environmental warnings about runoff and aquatic toxicity. A spray solution of 1 part 3% hydrogen peroxide to 6 parts water applied directly to affected foliage kills powdery mildew spores on contact through oxidation. The compound breaks down into water and oxygen within minutes of application, leaving absolutely no residue on leaves, fruit, or soil. The same solution works on botrytis, downy mildew, early blight, and several other common fungal diseases. You can spray a tomato plant in the morning and eat the fruit that afternoon without concern. That is something no commercial fungicide label will ever tell you. Powdery mildew is a problem you can see developing. The next application targets something you almost never see until significant damage has already occurred underground. Number 23. It sterilizes soil before planting without chemicals. Reusing potting soil or planting into ground that previously hosted diseased crops transfers fungal spores, pest eggs, and pathogenic bacteria directly to new planting. The garden industry's answer is sterilized, seed-starting mix at premium pricing, sold to you in fresh bags every single season. A drench of 1 part 3% hydrogen peroxide to 1 part water applied to potting mix or garden beds before planting oxidizes pathogens, fungal spores, and pest eggs in the top layer of soil. The solution breaks down within 30 to 60 minutes, leaving nothing behind except water and oxygen. The oxygen released during breakdown also loosens compacted soil slightly, improving aeration before roots ever arrive. You sterilize and condition the soil in a single step, and you can plant into it the same day. The next application works before seeds even touch the soil, at the exact moment when germination success is determined. Number 22. It dramatically improves germination rates. Seed packets give you germination percentages and temperature ranges, but they never mention that soaking seeds in diluted hydrogen peroxide before planting consistently produces faster germination and higher success rates across a wide range of species. That information does not appear on packaging because it eliminates the need to buy fresh seed when germination rates disappoint. The mechanism is direct. Hydrogen peroxide softens the outer seed coat slightly, allowing water to penetrate more effectively. Simultaneously, it kills mold, bacteria, and fungal spores present on the seed surface that cause pre-germination rot and damping off in seed trays. Soak seeds in 1 teaspoon of 3% hydrogen peroxide per cup of water for 2 to 8 hours before planting. Harder coated seeds, like beets and peppers, benefit from longer soaking. Smaller seeds like lettuce need only a short soak. Gardeners who do this consistently report germination beginning 1 to 3 days earlier, with noticeably higher rates of successful emergence across the entire tray. Faster germination gets plants established sooner, and the next application keeps them alive once they are in the ground by handling the pest problem that arrives every season without fail. Number 21. It kills soft-bodied pests without harming beneficial insects. Broad-spectrum insecticides kill everything. Aphids die, but so do the ladybugs, lacewings, and parasitic wasps that would have controlled those aphids naturally. The result is a cycle of dependency where pest populations recover faster than beneficial populations, requiring more and more product with each passing season. 3% hydrogen peroxide applied directly to aphid colonies, spider mite infestations, and fungus gnat populations kills soft-bodied insects immediately through oxidative damage to their cell membranes. Because it breaks down within minutes, it leaves no persistent residue and poses no ongoing risk to beneficial insects that arrive later. You can spray an infested plant in the morning, and by afternoon, the predatory insects that patrol your garden are completely unaffected by the treatment. For fungus gnats specifically, whose larvae damage roots in moist potting soil, a soil drench of diluted hydrogen peroxide kills larvae in the top layer of soil while leaving the plant entirely unharmed. Targeted pest control without biological collateral damage is the goal, and the next application uses the same chemistry to do something that helps plants grow faster than anything on a fertilizer label will promise. Number 20. It oxygenates the root zone and accelerates growth. Plant roots require oxygen to function. In compacted, waterlogged, or heavily cultivated soil, oxygen levels in the root zone drop significantly, and root metabolism slows. Plants growing in low oxygen soil look dull, grow slowly, and become more susceptible to disease, even when nutrient levels are adequate. Hydrogen peroxide solution reaching the root zone releases free oxygen directly into the surrounding soil. This additional oxygen accelerates cellular respiration in root tissue, speeds nutrient uptake, and promotes rapid development of fine root hairs, which are the structures responsible for most water and nutrient absorption. Gardeners adding 1 teaspoon of 3% solution per gallon of watering water consistently observe more vigorous growth compared to untreated plants under identical conditions. This adds no nutrients. It adds oxygen, which allows plants to use the nutrients already in the soil far more efficiently. In many garden situations, oxygen availability is the limiting factor, not the nutrient supply. Oxygen in the root zone drives growth, and the next application protects that growth at one of the most critical and frequently failed moments in the plant life cycle. Number 19. It prevents transplant shock and saves cuttings. When roots are disturbed during repotting or transplanting, fine root hairs tear away, and the plant's ability to uptake water collapses temporarily. In that weakened state, opportunistic pathogens in the surrounding soil attack damaged root tissue before recovery can begin. This is why healthy plants in good soil still look wilted and stressed for days after transplanting. Watering transplants with 1 teaspoon of 3% hydrogen peroxide per gallon of water immediately after planting kills surface pathogens around damaged roots, while simultaneously delivering a burst of oxygen that accelerates new root hair development. For cuttings placed in water or rooting medium, the same solution suppresses bacterial rot at the cut stem before roots develop. Cuttings treated this way show notably lower rates of stem rot and faster root initiation compared to untreated cuttings under the same conditions. For gardeners who propagate herbs, houseplants, and fruiting shrubs from cuttings, this single treatment can dramatically improve success rates without any additional products. Cuttings and transplants are the most vulnerable plants you grow, and the next application protects the tools you use to tend them. Number 18. It disinfects pruning tools and stops disease spreading. Every time you cut a diseased plant and use the same tool on a healthy one, you transfer pathogens directly from one plant to the other. This is how bacterial cankers, fungal blights, and viral diseases spread through entire orchards and garden beds. The standard recommendation is bleach solution between cuts, but bleach corrodes metal, degrades tool quality over time, and requires rinsing steps that most gardeners skip because the process takes too long. 3% hydrogen peroxide applied directly to pruning blades between cuts kills bacteria, fungal spores, and most viral particles on contact. It does not corrode metal. It requires no rinsing. It evaporates within seconds, leaving tools dry and ready for the next cut. A small spray bottle of 3% hydrogen peroxide kept in your tool bag turns disease-safe pruning from an inconvenient multi-step process into something that takes less than 3 seconds between cuts. Cleaner tools protect every plant they touch, and the next application protects the water those plants drink every time you irrigate them. Number 17. It purifies irrigation water and clears biofilm. From Lines Municipal, tap water contains chlorine and chloramine compounds present to make water safe for drinking. But in garden soil, these compounds suppress the beneficial microbiology that drives nutrient cycling and root health. Stored rainwater carries the opposite problem: algae, bacteria, and organic contaminants that block irrigation lines and introduce pathogens to the root zone. Adding roughly 3 milliliters of 3% hydrogen peroxide per liter of irrigation water neutralizes chlorine and chloramine through oxidation, while simultaneously killing algae and bacterial contamination present in stored water. The peroxide breaks down within minutes after application, leaving clean, oxygenated water with no residual disinfectants. For drip irrigation and soaker hose systems, a monthly flush of diluted hydrogen peroxide through the lines prevents the biofilm buildup that eventually leads to blockages and uneven water distribution, without requiring disassembly of the system. Cleaner water feeds healthier plants. Now, the next application works on the containers and surfaces those plants live in before the water even arrives. Number 16. It removes algae and biofilm from pots and trays. The green slime coating the inside of reused pots, seed trays, and greenhouse staging is not cosmetic. Algae and biofilm on these surfaces harbor fungal spores, bacterial pathogens, and pest eggs that contaminate new plantings every time equipment is reused. Bleach dissolves the coating but corrodes surfaces, leaves residue that harms soil biology, and requires careful rinsing before equipment is safe to replant into. 3% hydrogen peroxide sprayed onto algae-covered surfaces breaks down algae cell walls through oxidation, dissolving the coating within minutes without scrubbing. On porous terracotta and unglazed ceramic, it penetrates deeper than bleach and reaches spores embedded in the material that surface cleaning misses entirely. Because it breaks down to water and oxygen, treated pots can be filled with soil and planted immediately with no rinsing required and no waiting period. The same application on greenhouse glass and cold frame covers removes algae growth that reduces light transmission and creates the humid, disease-prone microclimates that damage every plant inside. Clean equipment protects your plants every season. The next application protects something that most gardeners spend far more money maintaining than they need to. Number 15. It treats lawn fungal disease. Without harming grass, lawn fungicides are among the most expensive repeat purchase products in the entire garden industry. Brown patch, dollar spot, red thread, and rust are recurring seasonal problems that product manufacturers have built entire product categories around, requiring multiple applications per season at significant cost each time. Half a cup of 3% hydrogen peroxide per gallon of water, applied through a hose-end sprayer over affected turf, treats active fungal infections across large lawn areas for a fraction of the cost of a single commercial fungicide application. The oxidative action kills active fungal mycelium in the thatch layer and on leaf surfaces without harming grass plants, or the beneficial fungi associated with healthy turf root systems. The treatment also accelerates decomposition of dead material in the thatch layer, reducing its depth over time. Excessive thatch is itself a contributing factor to lawn disease, creating the humid microclimate where fungal pathogens thrive. Hydrogen peroxide addresses both the active infection and the structural condition that promotes its return. Lawn disease eats through budgets fast. Our next application works on the indoor equivalent of that problem, the enclosed growing spaces where most gardeners start their entire season. Number 14. It controls mold in indoor growing environments. Indoor growing creates conditions that outdoor gardens rarely replicate. Consistent warmth, limited air circulation, high humidity around dense canopies, and artificial lighting that cannot dry leaf surfaces the way sunlight does. Mold establishes and spreads through these environments rapidly, moving from plant to plant through airborne spores in ways that outdoor airflow naturally prevent. A weekly preventive spray of 1 part 3% hydrogen peroxide to 5 parts water applied to plant surfaces and growing medium surfaces creates a chemical environment that disrupts mold spore germination and attachment without harming plant tissue at this concentration. For grow tents, propagation chambers, and sealed greenhouse environments, adding hydrogen peroxide to misting systems at low concentrations maintains ambient conditions that significantly reduce mold incidence compared to untreated environments. This application is most valuable during late winter seed starting, when indoor conditions are at their most humid, heating systems run continuously, and damping off rates peak among seedlings crowded in propagation trays. Indoor mold is the quiet destroyer of early season crops. The next application improves the system that feeds those crops once they are established outdoors. Number 13. It accelerates composting and eliminates odor. Compost that smells bad has gone anaerobic. The beneficial decomposition that produces rich humus is driven by aerobic bacteria and fungi that require oxygen. When a pile becomes too wet or compacted, oxygen depletes, anaerobic bacteria take over, and the pile produces hydrogen sulfide and ammonia, which are the gases responsible for the smell that makes gardeners avoid their own compost. Applying hydrogen peroxide solution to an anaerobic compost pile reoxygenates the material, kills the anaerobic bacteria causing the odor, and creates conditions where aerobic decomposers can reestablish and resume active breakdown. The oxygen released also breaks up matted, wet layers that restrict airflow deep within the heap, where physical turning cannot reach. A single treatment can shift an odorous pile back to active, odor-free decomposition within 48 to 72 hours. For gardeners who vermicompost, pre-treating new material with diluted hydrogen peroxide before adding it to the worm bin kills pathogens and pest eggs without harming worms that arrive later. Better compost means better soil. The next application improves the soil itself in the exact location where most gardens face their most persistent challenge. Number 12. It breaks up soil. Compaction in container gardens. Containers compact over time. Repeated watering pushes fine particles into air pockets. And without the earthworm activity and root turnover that naturally aerates in-ground soil, container mix becomes dense, poorly draining, and oxygen depleted long before the pot looks full or the plant shows obvious distress. By the time growth slows noticeably, root function has already been compromised for weeks. Regular irrigation with 1 teaspoon of 3% hydrogen peroxide per gallon of water releases oxygen throughout the container's root zone continuously, compensating for the lack of natural aeration that in-ground soil receives. The steady oxygen supply keeps root metabolism active, prevents anaerobic zones from forming around saturated lower layers, and reduces the frequency with which containers need to be refreshed or repotted. For long-term container plantings like established herbs, dwarf fruit trees, and perennial shrubs in pots, this practice extends the productive life of the planting significantly without requiring repotting or soil replacement. Container aeration is a slow, invisible problem, and the next application addresses something that happens far more visibly at the moment when plants are at their most exposed. Number 11. It protects bare soil from crust formation and weed pressure. Bare soil after rain develops a surface crust. Water compacts the top layer. Fine particles seal together as it dries, and the resulting crust blocks seedling emergence, reduces water infiltration, and creates the smooth, open surface conditions that wind-blown and water-carried weed seeds need to establish. Most gardeners respond by buying mulch, but there is a soil-level treatment that addresses the biological component of this problem directly. Applying diluted hydrogen peroxide to bare soil between plantings kills surface weed seeds and the mold spores that help weed seedlings establish in disturbed ground. It simultaneously oxygenates the top layer, improving its structure and making it less prone to the particle compaction that forms crust. The treatment takes seconds to apply and costs almost nothing per square meter. Combined with a thin layer of compost or a fast-establishing cover crop, this treatment eliminates the window of opportunity that weed seeds exploit between plantings. Bare soil is vulnerable soil. The next application turns that vulnerability into an opportunity by preparing it for the most important growth stage in any gardening calendar. Number 10. It supports seedling recovery from damping off. Damping off kills seedlings at the soil line, collapsing the stem of an otherwise healthy-looking seedling overnight. It is caused by several fungal pathogens, including Rhizoctonia and Fusarium species, that thrive in the warm, humid, crowded conditions of indoor seed trays. Once it appears, it spreads across a tray rapidly, and most gardeners lose entire batches before understanding what happened. At the first sign of damping off in a seed tray, a light drench of 1 part 3% hydrogen peroxide to 5 parts water applied to the soil surface kills active fungal mycelium at the base of affected seedlings and in the surrounding medium. Seedlings at early infection stages can recover if the treatment is applied promptly. Healthy seedlings in the same tray are protected by the oxygen barrier the treatment creates in the surrounding soil. This is not a product sold for this purpose. There is nothing on the garden center shelf labeled for damping off that works faster, more safely, or at lower cost. Damping off happens fast. Our next application deals with something that develops just as quickly on the other side of the glass. In the outdoor beds, where established plants face their seasonal peak of disease pressure. Number 9. It sanitizes harvesting equipment and extends produce. Shelf life. The same pathogen transfer that affects pruning tools affects harvesting equipment. Knives, scissors, baskets, and crates carry mold spores, bacterial contamination, and insect eggs from one harvest to the next. In humid conditions, a contaminated harvest basket can inoculate every piece of produce placed in it, accelerating decay that most gardeners attribute simply to the produce itself rather than to the equipment that carried it. Spraying harvest equipment with 3% hydrogen peroxide between uses kills surface contamination without leaving chemical residue on food contact surfaces. It requires no rinsing and no waiting time. Applied to the surface of freshly harvested produce as a light spray before storage, it kills surface mold spores and bacteria that accelerate decay, extending the time produce remains usable after harvest by several days in many cases. For gardeners producing significant quantities of soft fruit, salad leaves, and fresh herbs, this practice reduces waste substantially without any chemical inputs that would affect flavor or food safety. Post-harvest care protects the crops you have already grown. The next application protects the structures you grow them in. Number 8. It cleans and protects greenhouse glass and polytunnel film. Algae on greenhouse glass reduces light transmission. Even a thin green coating across the interior surface of a greenhouse can reduce light levels meaningfully during the low light months of late winter and early spring, exactly when seedlings need maximum light intensity most. Cleaning greenhouse glass with soap and water removes surface algae temporarily, but does not penetrate the microscopic pores where spores survive and from which regrowth begins within weeks. 3% hydrogen peroxide sprayed directly onto greenhouse glass or polytunnel film penetrates surface algae and kills embedded spores, producing results that last significantly longer than soap cleaning. On plastic film surfaces, it is gentler than many commercial cleaning agents that degrade the UV stabilizing coatings applied to polytunnel film to extend its working life. A treatment applied in late winter before the main growing season, and again in early autumn before low light conditions return, keeps growing structures clean during the 2 periods when light transmission matters most to plant productivity. Clean growing structures improve light. The next application improves one of the most fundamental inputs your garden receives: the quality of the water that reaches every plant every day. Number 7. It removes chlorine from tap water for sensitive plants. Chlorine in municipal water is a known suppressant of mycorrhizal fungi, the soil fungi that form symbiotic relationships with plant roots and dramatically extend their effective reach for water and nutrients. Gardeners growing in mycorrhizae-inoculated soil or in living soil systems where biological activity is cultivated deliberately are undermining that investment every time they water with untreated tap water. Adding 1 milliliter of 3% hydrogen peroxide per liter of tap water neutralizes chlorine and chloramine through oxidation before the water reaches the soil. The peroxide itself breaks down within minutes, leaving clean, dechlorinated water that supports rather than suppresses the soil biology it reaches. For seed starting and propagation, where beneficial bacteria on the seed coat and in the germination medium are part of the establishment process, dechlorinated water improves outcomes measurably. For fermented plant feeds, compost teas, and other biological soil amendments that contain living microorganisms, using chlorine-neutralized water prevents the killing of the beneficial organisms that make those amendments valuable. Water quality affects everything that follows. The next application brings hydrogen peroxide directly to one of the places where garden water use is most intensive and most prone to biology-destroying chemical buildup. Number 6. It clears hydroponic and aquaponic systems of pathogens. Recirculating water systems concentrate problems. A pathogen that enters a hydroponic reservoir reaches every plant in the system within hours. And because roots are suspended in water rather than buffered by soil, infection progresses faster than in any in-ground system. Hydrogen peroxide at low concentrations, typically between 1 and 3 milliliters of 3% solution per 10 liters of reservoir water, maintains water quality by killing bacterial and algal contamination without accumulating in the system or damaging living roots at correct concentrations. For aquaponic systems, where fish are present and chemical treatments are severely restricted, very low concentration hydrogen peroxide treatments, applied carefully, can address algae and bacterial bloom problems without harming fish, because it breaks down completely before reaching toxic thresholds for aquatic life at appropriate dilutions. This is the application where concentration accuracy matters most. Too little, and the treatment is ineffective. Too much, and root tissue is damaged. The 3% pharmaceutical concentration is the correct starting point for all dilution calculations. Hydroponic systems are the most intensive growing environments home gardeners use. The next application works in the least intensive one, in the spaces between established plants where weeds and soil problems develop while attention is focused elsewhere. Number 5. It suppresses soil-borne weed seeds. Between crop rotations. Between crop cycles, weed seeds in the top layer of soil wait for the light and warmth that tillage and planting activity provides. Standard advice is to till, which brings deeper weed seeds to the surface and multiplies the problem, or to cover with landscape fabric, which gardeners end up buying and replacing repeatedly as it degrades. Applying a solution of 1 part 3% hydrogen peroxide to 2 parts water directly to bare soil between crops kills germinating weed seeds in the top layer through oxidative damage before they establish. Because the treatment breaks down completely, a subsequent planting can go into the same ground within hours without any chemical interference with germination or seedling development. Repeated applications between successive plantings over a single season progressively deplete the surface weed seed bank, reducing weed pressure measurably over time without the soil disturbance that perpetuates the problem. Less weed pressure means less competition for established crops. The next application deals with competition of a different kind. The mineral competition between depleted soil and demanding plants that drains productivity from gardens that never receive the soil treatment they need. Number 4. It supports soil microbiology recovery after chemical treatment. Gardens that have received synthetic pesticide or herbicide treatments often show suppressed soil biology for extended periods after application. Beneficial bacteria, fungi, and the microfauna that depend on them are reduced. Nutrient cycling slows, and plant health suffers in ways that are not always immediately connected to the chemical application that caused them. Applying hydrogen peroxide solution to chemically treated soil, followed by additions of compost or biological inoculants, creates the aerobic, oxygen-rich conditions that beneficial soil organisms require to re-establish quickly. The peroxide first oxidizes residual chemical compounds in the soil surface, then breaks down and leaves behind the oxygenated environment that aerobic biology colonizes fastest. This application does not remove deeply embedded soil contamination, but it addresses the surface layer where most biological activity occurs and where recovery begins. Combined with organic matter additions and cessation of chemical inputs, it accelerates the transition from chemically dependent to biologically active soil faster than passive recovery allows. Biological recovery transforms struggling soil. The final use of hydrogen peroxide brings every benefit on this list into a single daily practice that costs almost nothing and replaces a significant portion of what the garden industry depends on you buying every season. Number 3. It works as a complete foliar health spray for stressed plants. Plants under stress from heat, drought, nutrient deficiency, or pest pressure show it in their foliage first. Leaves yellow, mottle, curl, or develop surface lesions that represent a combination of environmental stress, pathogen activity, and compromised cellular function. The garden industry responds with a different foliar spray product for each symptom, most of which contain synthetic compounds that address the surface appearance without improving the underlying plant health. A foliar spray of 1 part 3% hydrogen peroxide to 8 parts water applied to stressed foliage delivers oxygen directly to leaf cells through stomata and surface absorption. This oxygen supports cellular repair processes, kills any surface pathogen contributing to the visual symptoms, and creates a surface environment inhospitable to further infection or pest colonization. Used weekly as a preventive measure during high disease pressure periods and applied reactively when stress symptoms first appear, this spray reduces the need for specialized foliar products across the full range of common plant health problems. It works on vegetables, ornamentals, fruit trees, and houseplants equally, at the same concentration, from the same bottle. One spray for many problems is powerful, but the final application on this list is the one that makes all the others more effective by addressing the foundational condition that determines how well every garden input performs. Number 2, it improves soil structure and drainage. In heavy clay, clay soil drains poorly because the fine particles pack together tightly, excluding oxygen and creating the anaerobic conditions that slow root growth and promote root disease. Gardeners add grit, sand, and organic matter to address this mechanically. But the biological dimension of clay soil problems, the dominance of anaerobic organisms that produce compounds toxic to plant roots, is rarely addressed directly. Periodic drenching of heavy clay soil with diluted hydrogen peroxide oxidizes the anaerobic compounds accumulated in poorly drained layers, kills anaerobic pathogen populations, and delivers the oxygen burst that allows aerobic organisms to begin colonizing the previously hostile environment. As aerobic microbial populations establish, they produce enzymes and organic acids that physically aggregate clay particles into larger clumps, improving drainage and aeration through biological action rather than mechanical tillage. This is a slow process that requires consistent application over multiple seasons, but it works with the biology of the soil rather than against it, producing lasting structural improvement rather than the temporary improvement of mechanical amendment that reverts to compaction within a season. Improved soil structure benefits every plant you grow. The final application brings every benefit on this list together into a practice that experienced organic growers have used quietly for years, while everyone else kept buying bags of product they did not need. Number 1, it creates a complete low-cost garden health system. Every application on this list addresses a different problem: root disease, fungal infection, pest damage, soil compaction, poor germination, transplant shock, tool contamination, water quality, weed pressure, biological recovery. These are the problems that drive gardeners back to garden centenarians season after season, spending on product after product, each one targeted, each one priced separately, each one requiring replacement when it runs out. Hydrogen peroxide addresses all of them. One compound, available everywhere, in a brown bottle that costs under $2, at concentrations and dilutions that are safe, effective, and non-toxic to people, pets, and the soil biology that healthy gardens depend on. The complete protocol is straightforward. Soak seeds before planting. Drench soil before planting. Water transplants in immediately after moving them. Spray foliage preventively every 10 to 14 days. Treat irrigation water monthly. Spray tools between cuts. Clean containers between seasons. Drench compost when it goes anaerobic. Apply to bare soil between crops. Each step is fast. Each step is inexpensive. Each step leaves no residue. Combined, they address the majority of problems that the garden industry charges you separately to solve. And they do it with a compound whose only breakdown products are water and oxygen. One rule applies across every application. Use 3% pharmaceutical hydrogen peroxide, the standard brown bottle from any pharmacy. The 35% food-grade versions sold online are dangerously reactive, cause chemical burns, and are not necessary for any application in a home garden. Standard 3%, diluted appropriately, is all you need. The garden industry has not deliberately hidden this from you, but it has had no reason to tell you about it. And that distinction matters when you calculate what you have spent on separate products over the years to solve problems that one bottle could have handled all along. Before you go, if you are ready to stop buying a different product for every problem, subscribe now. And if you think hydrogen peroxide is the only thing the industry has let you overpay to solve, click the next video. What they have done to the soil amendment market makes everything you just read look like a small saving. We will see you there.